All right, we're looking at the CYUs for Lesson 32, our more advanced related rates. So translate each of the following sentences into mathematical statements using derivatives. This first one tells me the height of water is increasing at 2 feet per hour. I see dH dt equals 2. My units are feet per hour. Water is pouring into the cone, so I'm adding water into the cone. dV dt is 7 cubic inches per minute. The radius of the surface of the water is decreasing at 1.5 inches per minute. dr dt is negative 1.5 inches per minute. All right, conical tank has a height of 10 feet and a radius of 6 feet. I'm going to go ahead and make a sketch. There's my cone, a radius of 6, a height of 10. All right, determine the relationship between the height of the water and the radius of the surface. So I said height of 10 and I wrote h, so I'm going to add in h equals 10, r equals 6. I know that I'm always going to have similar triangles in this cone, so I can say, so relationship between height of the water and radius of the surface, so I'm going to say h over r is equal to 10 over 6, and I can reduce that to 5 over 3. Write a formula for the volume of water as a function of h alone. Well, I'm going to come up here and get h alone then. H is equal to 5r over 3. Volume of a cone is 1/3 pi r squared h. Put the 3 on the bottom. Now I'm going to replace, a function of h alone. So I want h to be alone. I don't want my r to be alone. So actually, I really wanted to take this and solve for r. So r is equal to 3/5 h. So I'm going to come back and substitute this way. So volume is equal to pi over 3 over 5h squared times h. I'm going to want to simplify this because I don't want to get confused with my constants. So I'm going to have pi over 3 times 9 over 25 h cubed. This I could simplify more, or I can just leave it knowing that that is just a constant. That whole part of the expression is a constant. A function of r alone, well, now I'm going to use this. So pi r squared times 5 over 3 r all over 3. Well, that's the same as pi r cubed with the 5. That 3 is really in the denominator, so I have a 9 down in the denominator. Water is pouring into the cone at a rate of 5 cubic inches per minute. So dV dt is 5 cubic inches per minute. How fast is the radius changing? So I want dr dt. Height of the water is 4 inches. Well, I want to know dr dt, so I want to use this formula. So I'm going to differentiate. Left side is dV dt. Derivative of this is going to be implicit. So 3 times 5 is going to be 15 over 9. That pi is still just a constant. R squared times dr dt. When the height is 4 inches, I know from this formula up here that if the height is 4 inches, then my radius is going to be 3 times 4 is 12 over 5. So at h equals 4, r equals 3 times 4 over 5. So now I can come back and substitute. I know dV dt is 5. 15 over 9 pi, 12 over 5 squared times dr dt. Now I could simplify this, or I can just get my dr dt alone. So I'm going to have 5 divided by 15 over 9 pi times 12 over 5 squared. My units, though, I definitely need those. Those are going to be inches per minute.